Good morning, everyone. This is your teacher, Miss Rita. Today we will continue explaining Chapter 2, Lesson 1, States of Matter. So please go ahead and open your books to page 46. Today we will be correcting the homework, studying the relationship between the temperature and the pressure of a gas, and solving some extra exercises. Let's start by correcting the homework. So please open your books to page 45, figure 5. You have to describe the movement and the arrangement of particles in a gas. The particles in a gas are far away, so they move in all different directions, spreading apart and filling all the available space, and this is why they have indefinite volumes. On page 46, do the math. You have to calculate the pressure of a gas that exerts a force of 5,610 newtons on an area of 0.342 square meter. So to calculate the pressure, we have to divide the force by the area. By dividing them, we get 16,400 Pascal. On page 46, figure 6, part A, you have a girl inflating a balloon. When she is doing so, the number of particles inside the balloon will increase. And we previously said that when the number of particles increases, the pressure will also increase. In part B, you have a girl deflating a balloon. So the number of particles inside the balloon will decrease. And we learned that when the number of particles decreases, the pressure will also decrease. Exercise 1. A gas exerts a force of 10 Newton on an area of 0.52 square meter. Calculate this gas pressure. To calculate the pressure, we have to divide the force by the area. So we have 10 Newton divided by 0.52 square meter. We get 19.23 Pascal. Exercise 2. A gas exerts a pressure of 600 Pascal on an area of 0.45 square meter. Calculate the force exerted by this gas. Force is equal to pressure times area equal to 600 Pascal times 0.45 square meter equal to 217 newtons. Now let's move on and explain the relationship between the temperature and the pressure of a gas. But before we do so, let's do a quick revision about temperature. So temperature is how fast the particles in a substance are moving. If the particles are moving fast, it means the substance is warm. If they are moving slowly, it means the substance is cold. Now if you look at the following picture, you can see that when the gas is cold, the particles will hit the walls of the container less times than if the gas is hot. We previously said that pressure is the force of the gas particles on the walls of the container. So if the particles hit the walls of the container harder, they will exert a higher pressure. From what we just said, we can conclude that if the temperature of a gas increases, then the particles will move faster. When they move faster, they will hit the walls of the container harder and they will exert a higher pressure, which means that a hot gas can exert a higher pressure than a cold gas. Now open your books to page 47, figure 7. The question is, Why are the hot gas particles moving faster than the cool gas particles? The answer is the hotter gas particles are moving faster because they have more energy of motion, so they can move faster than the cool gas. On page 47, number 3, part A, you have to explain how the movement of the gas particles is related to the pressure exerted by this gas. So as we previously said, the moving gas particles collide or exert a force on the walls of the container, so they push the walls of the container and exert a pressure. On part B, the question is, why does pumping more air into a basketball increases the pressure inside the ball? So the answer is, we said when we increase the number of particles in a container, these particles will hit the walls of the container more times, and this will increase the outward push and the pressure of the gas on the container. In this case, the container is the basketball. For next time, I need you please to copy the following exercises on your copybooks and try to solve them.